Good afternoon, everyone. We are in the week 7 of the Geotechnical Engineering 2 coursework. And this is the coursework which is running for the 12 weeks, and it's maybe possible that the one additional week may be there in which the total revision of the course will taken care of. So till that we are reading about the shear stress, shear strength, and the different type of test which is required to perform those tests. From today we onwards we are going moving to the new topic, that is the earth pressure. In earlier classes we have taken the different concepts, problems, and understood at how to tackle with the different types of problems. Most of the problems are from the standard books or maybe some competitive examination which I try to take in the previous classes. From today onward, we are moving to the new topic. First of all, we briefly take some of the conceptual clarity before moving ahead, and afterwards, we will going to take the some of the small problems in the last. Okay, so before starting that, there are some instructions which I want to put on over here. Like this class is going to be run for the entirely 2 hours, that is from 3 to 5. And in the meanwhile, if due to any issue, due to any internet connection, if the connection get disconnected, or maybe I am logged out due to some issue, so please be remain in the meeting. I will rejoin and take the class from there only. So now let us start. My name is Sumit Kumar. I am PhD research scholar at IITS and Dhanbad. This is the coursework named Geotechnical Engineering 2, which is taken by Professor D.N. Singh sir from the IIT Bombay. And this coursework provide you various insights about the subjects and give you a better understanding about the practical implementation of the concepts you gather during the geotechnical engineering coursework one, and the practical implementation will also help the graduate students or the specific professional work in getting developing the knowledge and ensuring that they can apply it in the field to work in the industries or in the other sectors. Okay. So with this, we will start the today class. So we are going to read about today the term named as Earth pressure theory. So when the Earth pressure theory word comes, we should when bifurcate this word only, that is the Earth pressure theory. So here are the three words, and first is the Earth, and second is the pressure. So Earth in the Earth pressure theory, we read about the pressure which is applied by the Earth or the soil mass, how it impact the situation over there, and maybe some backfill may be there. So over here you can see the some images in which you see the log spiral, Coulomb, and the Rankine, this type of word. So these are the different Rankine and Coulombs are the researchers, experimentalists who have given some of the specific theory. On the basis of that we move ahead. So when we talk about the Earth pressure theory, we come across the word named press. So we all already know about the word pressure. So over here, what the pressure word it define? So over here, when we talk about when we say word pressure, we say that the pressure which is applied by the soil mass on the wall. So in the earth pressure theory, two type of earth pressure, active earth pressure and passive earth pressure we come across as we move ahead. So there may be it's not like what we read in the literature, like the active voice, passive voice. Over here, when we talk about the earth pressure theory, like active earth pressure or the passive earth pressure, so the soil mass apply the pressure on the wall toward or away. Totally in that manner, it replicate the field situation. Okay, so we will move ahead first of all with the assumptions and then move ahead with the concepts. Then the failure surface angle which is met with the axis will be what and how, that we will see as we go ahead slide by slide. Okay, so first of all we start with the term, that is the Rankine earth pressure theory. As you have seen in the previous diagram, Rankine column and the different words are there. As I have already said, they are the researchers, experimentalists who have given those theory. So we are going to read those theory over here. So the Rankine earth pressure theory, and in this case also there are the three conditions get developed. That is at rest condition, in the active and passive earth pressure condition, and the formulation is also developed to give a good idea to the different research analysts or the people who are working in that field, or the different engineers who are implementing those theory to get the value of the pressure which is applied so that they can design accordingly. Okay, so to analyze the pressure relation between the retaining wall and the soil mass, the most commonly used theory is the Rankine earth pressure theory, right? So, when the earth pressure theory and we are talking about the Rankine earth pressure theory, there are the primarily three conditions is possible. One, that the soil is there and the wall is there. There is no pressure is applied between them. So that condition is said to be the wall at rest condition. The second condition arises in the active earth pressure theory. In the active earth pressure theory, the soil mass is moving away from the wall. If a wall is there, the soil mass is moving away from the wall. That condition is said to be active earth pressure theory, active earth pressure condition. And for the subsequent condition, when the wall is there and the soil mass is try to move the wall away from its position, that condition is said to be the passive earth pressure condition. In the Rankine theory, it assumes that the wall is smooth and soil is cohesionless. This theory has also extended to the cohesive soil, as some other scientists came and who extended this theory. But initially, Rankine has given this theory for the cohesionless soil. Excuse me, and it's water. Okay. Okay. So we are talking about the Rankine as pressure theory. So earlier it is given for the cohesionless soil. Later it is extended for the cohesive soil as well, and we will come across those things as well as we move ahead. Okay. So when we talk about the retaining wall, as I have said that the three condition at rest in at inactive pressure condition, passive pressure condition, three condition could be established. So in rest condition, the soil mass and the wall are not applying any pressure on one another. While in the second case, when the active case is there, the soil mass is moving away from the back wall, and in the third condition, the soil mass is moving toward the. Okay, so every time it is not possible to place the soil until it has the greater shear strength. So we construct a wall to keep it in the place, right? You have seen at the several places when the highway or the expressway are constructed, it is relatively at the higher elevation from the normal ground places. Why? Because we want to a high speed transport over there. We don't want any disturbance or any small vehicles or the cattle may came over there and could cause the some type of accident or restrict the traffic, and the speed should be restricted because of that soil is filled over there. But is it possible that if we fill the soil and it remain over there in the same condition? Over there also a type of wall need to be created to bound the soil within that specific cross section so that the soil mass doesn't spill out from that cross section. That wall is created and the pressure applied by the soil mass within that or below behind that or ahead of that is ultimately replicated in the form of the active and passive earth pressure, right? Okay, so we construct a wall to keep it in place and we fill the soil back to it. It is called a backfill when the soil is filled behind the wall to sustain the soil over there. That wall, that soil is said to be backfill, and the wall is called to be the retaining wall because it retains the soil mass which is filled back of that wall is the wall is said to be retaining wall. Now, If the wall hadn't been there, the soil mass could have come out, which implied that the soil mass is applying some pressure on the wall that is called the earth pressure. So we should design the retaining wall against the earth pressure. Right. That is it. Now, see condition over here. Over here, you can see that there is a wall is constructed. Wall has been shown. Okay, I will use the pen to explain it more clearly. See, over here, you can see this is a wall, right? And the soil is filled behind that. The soil is filled behind that. As you see, first of all, this wall is created and this restrain this soil, this restrict the soil to move toward this direction. So the vegetation or any other thing over here remain settled over there. So this wall is actually a retaining wall, and the soil behind this is said to be backfill, which is mentioned over here as well. So now consider the three situations. One situation is that the soil is restrained at its position and it doesn't apply any pressure on the wall. Rightly said. So that condition is said to be at rest condition. When we move to the second condition, in that condition, the soil mass is moving away from the wall. Soil mass is moving away from the wall. That condition is said to be active state condition because the soil is active and moving away from the wall. And in the subsequent condition is the condition in which the soil is trying to push the wall, uh, so that to break the wall and move out. So that condition is said to be passive earth pressure condition because in that condition the pressure is applied toward the soil. So I think so this point is very much clear. We will move ahead and discuss one by one the all the three condition and their earth pressure coefficient calculation as well. Okay. See, now you see when we talk about the design of a retaining wall. So while designing a retaining wall, some points need to be kept in mind. What are those points? Those points are that water does not have a shear strength, hence the stress in the vertical and horizontal direction are same. The second point is like the soil has some shear strength and the horizontal stress is a function of vertical stress. Okay, we talk about we have studied the shear stress, we have studied about the triaxial test. So consider a condition, just as example, uh, the condition in the active state. Okay, I will discuss this point later when once we discuss the active and passive state of stresses. Over there we will discuss, and at this point of time we will leave. Okay. Because there might be some chances if you are very much unaware about this topic, you might miss those things. Okay. So see the types of wall movement which is possible, as it has been said many times that the wall can attain the three conditions at a point of time. According to the wall position, earth pressure changes, and the three general conditions of walls are: first is that the wall is at rest, that the wall is not moving towards or away, it stands in the same position without affected by the soil at the backfill. The second condition, that the wall moves away from the backfill, as you have seen from that image, that the first of all there is a wall is there, and there is a wall is there and there is a hill at the back side, right? So over here you can see that in this condition what happened, that the wall is there, backfill is there, but both are in the static condition, they are not applying any pressure at one and another. That condition is in the rest condition, but the second condition could also be there, as the soil mass is able to flow in this direction, that is away from the wall. So that condition is said to be the active state condition. So the wall moves away from the wall, and in the subsequent condition, wall soil could also move toward the wall. So that movement of wall toward move toward the backfill is said to be the passive earth pressure condition. Okay. Now you see the how the three condition work in real life situation. So the first is the wall at rest. So in this condition, the wall and base of the wall are rigid, which make the wall stay at a single place without any movement. As it is discussed at the many times in today class only, over there it is said that they are static and they that stand at the place where should be. And as the wall does not move in any direction, the lateral strength, the ratio of change in area to the original area is zero because neither the wall nor the backfill moves in any direction. So the lateral strength remain unchanged. So the ratio of change in area is also remain the same. That is zero, which I mentioned over here. Okay. Now we move to the second condition. The first condition we have understood that the wall is there and the backfill is there, but they are not moving toward one another at any point of time. So now consider the second condition, in which the wall moves away from the backfill. Again, we construct a wall. This is a wall, and there is a backfill behind this. There is a backfill behind this. See, this is a backfill behind this, and in this condition this soil mass is moving, this soil mass is moving toward this direction, that is away from the wall. So this condition is said to be active earth pressure condition, right? Okay, so wall moves in one direction, that is far from the backfill. So wall and its base does not are not rigid in this. Here you can see, as you see, the backfill is there, the retaining wall is there. Either the backfill or the wall, the converse could also be possible. But over here you can see that the retaining wall is moving away from the backfill. Backfill pressure is so much. This soil is applying that much pressure so that it is pressing it out from its plane. So the wall moves away from the backfill, result in the condition in which the earth pressure is said to be in the active earth pressure condition because the pressure applied by the backfill compelled the wall over there to move away from the backfill. So that pressure, that earth pressure condition is said to be active earth pressure condition. Okay, now when we talk about this condition, we say that as the wall moves away from the soil because of this, some of the pressure of soil get relieved. As it is already said that first of all the backfill is there and the soil, a wall is constructed, so the amount of pressure is also over there on the soil at the backfill, but in the condition when the soil pressure is too much that the wall is moving away from the backfill, in that condition it is a normal thing to understand that in this condition the pressure on the soil which is there at the backfill is relatively released or relaxed, resulted in the resulted in the reduction of pressure over there. Hence, the shear resistance get mobilized and it is the opposite to the wall movement. The shear resistance is in the opposite direction, so the pressure in the horizontal direction get reduced. As the wall keeps moving away, we will reach the condition where the full shear resistance would be mobilized. After a point, there will not any further resistance, even the wall moves away. So after that condition, the horizontal pressure would be minimum. and it is said to be the active earth pressure condition. Okay, over here again the question could be framed from the triaxial test. You think over there what is the maximum principal stress and minimum principal stress? Over here, the stress applied in the vertical direction due to the soil mass at the specific section is the maximum principal, while the stress applied in the horizontal direction as it is released due to the movement of wall away from the backfill resulted in the reduction of the earth pressure in the horizontal direction. So over there that is the minor principal stress, and accordingly some other calculation could be conducted to understand the results. Okay, now move ahead. Moving ahead, when we talk about the passive earth pressure condition, so in this case, the wall moves towards the backfill. Over here again, I construct a wall. This is a wall, and when you see this wall, there is a backfill behind this. In this condition, this wall is moving toward the backfield. Wall is moving toward the backfield, resulted in the increase in pressure in the horizontal direction. So the pressure in the horizontal direction get increased. So the maximum principal plane is in this direction. Maximum principal stress is in the horizontal direction, and the minimum principal stress in the vertical direction. So, due to the mass of creating a wall and the speed at which it moves, the mass of the soil backfill tends to move upward. Rightly said, it is going to move upward. And as you see over here, as the retaining wall try to move toward the backfill, the shear resistance act in the same direction as a horizontal pressure. There will be the situation where the stress can't be the maximum than that the passive earth pressure. ठीक है? Okay, because you know over here when the wall is moving toward the backfill, the pressure in the horizontal direction is enormously high, because over there the soil also get more stresses, as it has been seen in the active earth pressure condition. As the wall move away, the stress get released, the soil get relaxed, but in this condition the vice versa condition could develop as the wall is moving toward the backfill. Okay, now we talk about the Rankine earth pressure theory, what it assumes. So it assumes that there is a no wall friction, as it has been already said that the wall is considered to be smooth. Okay, so it is said that the wall has no wall friction and the ground and the failure surfaces are straight planes, and that resultant force act parallel to the backfill slope. Okay. Now, when we say what happened in this case, okay, so we when we are talking about the cases which could take place over here during this condition. So, in the case of the retaining structure, the earth retained may be filled up the earth or the natural soil. So these backfill materials may exert a certain lateral pressure on the wall, and if the wall is rigid and does not move with the pressure jutted on the wall, the soil behind the wall will be in the state of the elastic equilibrium. And see a specific condition which is presented over here. Here we can consider a prismatic element E, as it has been shown in the figure. In the center of block you can see the figure is there in the backfill at the depth z. So we have considered this element from the backfill and taken from the depth z, as it is also represented in the figure. Over here you can see that the stress in the horizontal and vertical direction is shown, and in this case the value of sigma at a specific condition as kd equal to k gamma z, and Pa as 1 by 2 k gamma h square has been represented, and its position is located from the h by 3 from the base. So everything will be discussed over here in the step by step manner. First of all, we start with the basic consideration, then we move ahead in the detail to give you the better understanding of the thing which we are discussing over here. So first of all, you see that the element E is subjected to the following pressure. First is the vertical pressure, that is the gamma J. Second one is the lateral pressure sigma H, which is where you can see sigma H. We already see that the coefficient of earth pressure is the ratio of horizontal sigma h by sigma v, as you can see over here as well in the figure. On the central block, we over here the block E is shown over there. You can see the pressure is applied from the horizontal direction is sigma h, and the pressure applied from the vertical direction is sigma v. As you know that the ratio of this sigma h to the sigma v is the coefficient of earth pressure coefficient, and it is less than 1 for the active earth pressure condition and greater than 1 for the passive earth pressure condition. And why this is the case, you will understand very easily, because as you know that the wall is moving away from the backfill in the active earth pressure conditions. So over there the resultant pressure at the bottom section is also get reduced. To get that, the value of k is 1 by 3, but that not the case with the passive expression, because over there the condition get vice versa. So you see that the element E is subjected to the following pressure: vertical pressure sigma V H gamma Z, lateral pressure sigma H, and the effective unit weight over here is the G. That's not have so many relevance over there, but if we consider the backfill is homogeneous, then both the sigma V and sigma H increases rapidly with the depth Z. Obviously, and on in that case, the ratio of vertical and lateral pressure remain constant with respect to the depth. That is the sigma H by sigma V equal to sigma B by gamma Z equal to constant, and K constant K, that is K is the coefficient of earth pressure for the rest condition. Okay. Okay, so I will explain one thing over here with some drawings. Over here, something is mentioned which I think you need to understood. First of all, over here you see there is a section Z has been represented at a specific point. So first of all, what we do, we draw the effective stress diagram. So first of all, we take the value of gamma. Gamma is gamma over here. So first of all, we draw the overall edge like this, and that is gamma h, or at a specific section it is gamma z, because gamma is same as it has been sent, right? Oh, so if for the active earth pressure condition, as we say sigma h by sigma v equal to k. Okay, ठीक है. So sigma h by sigma v is k. So when we are calculating about the value of sigma h, the it is multiplied by the value k, that is the earth pressure coefficient, which may be earth pressure at rest condition k naught, earth pressure in active condition k a, and active stress in the passive condition h k p. Afterwards, when you multiply 1 by 2 into h into K gamma H, you will come to know that the resultant earth pressure is like 1 by 2 K gamma H square. He also mentioned over here that 0.25 K naught gamma H square. Now we talk about the Rankine earth pressure theory with some of the theoretical aspects over there. We say this theory was only applicable to the uniform cohesionless soil as originally proposed, but later in 1915 Bell extended the Rankine theory for the cohesive soil as well, and all the soil mass in the plastic equilibrium remain at the active passive earth pressure, and this means for every point in soil shear failure is just about to happen. And when we talk about in reality, only the part of soil mass will be in the plastic equilibrium in the real sense. because that is rarely the case. Now we talk about the assumption. As we have seen some assumption over there, we say that homogeneous isotropic over where we say that the considered to be smooth, wall is considered to be smooth, not rough. So we are moving ahead with the same consideration, but with the okay, sorry, in the same consideration, but with the specific approach over there. It is mentioned through the point wise. Okay, so we will go over there. Give me a minute. Okay, now we will talk about some new thing. So first of all, we start with the assumption of inclined field. So some of the important assumptions that the Rankine earth pressure theory are that the soil is isotropic homogeneous, it is said by me just now. Which means that the C, phi and gamma have the same value everywhere and they have the same value in the all direction at every point, that is the strength of a vertical plane is the same as that on the horizontal plane. So when you come to note this point, this theory is also applicable for the multi-layer soil having the different value of C and phi, C phi and gamma in the different layers, right? Okay. Now you see, when we are talking about the assumptions, some more assumption is also there that the wall is infinitely long, hence the problem may be faced, maybe analyzed in the only two directional dimensions. Geotechnical engineers consider this as a plane strain condition. The ground surface is a plane, although it does not necessarily needed to be level. This is then there is the no wall friction. The wall moves sufficiently to develop the active or the passive condition. The most critical shear surface is a plane. In reality, it is slightly concave up, but this is reasonable assumption that especially for the active case and it simplify the analysis. That's why we consider those assumptions and the resultant of the normal and the shear forces that act on the back of the wall is inclined at an angle parallel to the ground surface. So when we are talking about these assumptions become very much important because when you go across this course at the end of the course, you must have to take an exam to get your certification over there. These assumptions, what are the assumptions? These assumptions are very much important in the every examination over there. The syllabus is this thing we are even in the various competitive examination like the gate or engineering services over there or the state services over there. You can also see that the many of the questions from the assumption could be framed, which are very easy, but due to some of the glitch in the knowledge, some people make blunder over there, resulted in the reduction of their marks. So please be very patient to understand these things in a very good manner. Okay, now we talk about the Rankine earth pressure theory when the wall is at rest. So we will understand over here about this thing in a very interesting way. What is the important thing over here about this? You need to understood so that you develop a good understanding in the field that how we at the rest condition or in the active condition or in the passive condition we come to deploy our knowledge to explain the thing in a good manner. Okay. So we are talking about the Rankine earth pressure theory when the wall at rest condition. Over there, the coefficient of earth pressure is also there. It is not the factor that the coefficient of earth pressure is only calculated in the active or passive state of stress. It is calculated for the state of stress when the wall is at rest. But over here, the theory of the elasticity is used. Hence, there is a zero displacement, so the zero strain, and the soil is homogeneous, isotropic, and the semi-infinite. Elastic modulus and the Poisson ratio is constant for the total soil mass, and the coefficient of earth pressure at rest condition or the Rest earth pressure constant is defined as K naught, which is the ratio of lateral earth pressure to the vertical earth pressure. K naught equal to sigma h by sigma v. At any depth z, the value of sigma v is gamma z, where gamma is the unit weight, and the value of K naught in the real sense is written as for the rest condition as K naught is equal to. There are the two ways in which we write first in the term of the Poisson ratio mu by 1 minus mu is the one of the case, and second is 1 minus sine phi, where phi is the angle of internal section. Okay, I think so this much understanding is clear for everyone. So we will move on. Okay, over here you can see that the this thing is already written that for the elastic theory, the soil having the Poisson ratio mu, the coefficient of earth pressure in the rest condition is said to be mu by 1 minus mu. But when we move ahead to talk about the second term, we come across the knowledge about the Poisson ratio coefficient for in the term of phi. Over there we come to know that 1 minus sine phi. I have also framed the question in this direction also, so try to write it over your notebook so that we can take in one way all the problem confusion which could be there. Okay, now you see some more points over here. The at rest and the earth pressure coefficient cannot is mu by 1 minus mu is applicable for determining the active pressure in the clay for the stud system because of the cohesive property of the clay. There will be no lateral pressure extended in the in that condition when it is at rest, and it is also up to the some height at the time the excavation is made. However, with time the creep and the swelling of the clay will occur and a lateral pressure will develop. This coefficient takes characteristics of the clay into account and will always give a positive lateral pressure. Because over here we are using only the term like 1 minus sine phi by or mu by 1 minus mu, as the value of sine phi is always vary between 0 to 1. So when we say 1 minus sine phi, it never be positive, and when we say the second term as mu by 1 minus mu, the mu is also constant, and 1 minus mu is also always less than 1 for this cases. So this value is also remain for GT. Sorry. Okay. See, we are talking about some of the important facts over here. And what are that because of the cohesive property of clay, there will be no lateral pressure exerted in the rest condition. When we consider about the rest condition, we are not talking about the lateral pressure. This is because of the cohesive property of clay, and it is also applicable up to some height at the time of excavation is made. However, with the time, the creep and swelling of the clay will occur, and a lateral pressure will develop. This coefficient takes the characteristics of the clay into the account and will always give the positive lateral earth pressure. The lateral earth pressure acting on the wall of height h may be expressed as sigma h equal to k naught gamma h, the total pressure of the soil at rest condition is said to be 1 by 2 k naught gamma h square, and how it takes place is also need to be understood in a very good manner. So over here first of all you see a case in which we are drawing the effective stress diagram, and when we talk about the total pressure, so over here the value is gamma z, gamma h basically if the height is h, so this value is gamma h, and when we are talk about the active earth pressure in kilonewton per meter square, this value is K naught gamma H. And when we are going to calculate the resultant, we say the area of this is equal to total active earth pressure P naught, which is ultimately calculated as 1 by 2 into K naught gamma H, which is base, and sorry, what happened? Okay, think so. I need a eraser because some other things also get drawn, which I'm not interested of. Right. Okay. So I will take a pen again. K naught gamma H into H. So that is nothing but 1 by 2, 1 by 2 into K naught gamma H square. Right? Which is over mentioned over here. Okay. See, so that thing what we are talking about, that the lateral earth pressure acting on the wall at height h is K naught gamma h, which is represented in the figure, in the first figure. And when we calculate this area, we come across 0.5 into K naught gamma h square. So we called about the total pressure for the soil at crest for the rest condition, and we come already to know the value of K naught for the rest condition is mu by 1 minus mu or 1 minus sine phi, as I have mentioned that several times. So you need to understand and remember these things during the class work only, because I will also take some of the exemplar problem or the MCQ type problems before moving ahead in things at the end of the class. Now we talk about the K naught, and we already know that the value of K naught depend on the relative density of sand and the process by which the deposit was formed. So if the process does not involve the artificial tamping, the value of ranges from 0.4 for the loose sand to the zero point 0.6 for the dense sand. Tamping of the layer may increase it up to zero point 0.8. So from the elasticity theory, K naught equal to mu by 1 minus mu, where mu is the Poisson ratio, and the value could also be calculated as K naught equal to 1 minus sine phi, which is said by the Jackie in 1944 from their investigations on the different type of soil. So this value is also equally valid if the value of Poisson ratio is not known and only the angle of internal friction is found through some of the testing. So we can go ahead with the value as K naught equal to 1 minus sine phi, as well as the value of K naught as mu by 1 minus mu. Both are the correct case to calculate the earth pressure theory at rest, and we can calculate at the specific section in kilonewton per meter square or the total as area up to that point. That's only the case which we are interested in. Now you see some of the points which is mentioned over here, which is just for the information that like the for the saturated clay, the Poisson ratio value lies between zero point 0.4 and zero point 0.5, so the value of K naught between 0.67 and 1. Similarly, for the unsaturated clay, sandy clay, silty, the typical value of Poisson ratio is also mentioned, and edge on the value of Poisson ratio, the value of K naught. For the dense sand, coarse sand, fine grained sand, rock type material, everything, there are the range is provided from which we can choose the value to move ahead with our understanding of the thing which we are trying to come out with. Okay, now you see the Jackie who provided the value of K naught as 1 minus sine phi, where phi is the angle of internal friction. For the normally consolidated clay, the K naught is also suggested as the value as 0.19 plus 0.233 log IP, where IP is the plasticity index plus IP is W liquid limit minus plastic limit, and for the over consolidated clay, the value of earth pressure constant coefficient at rest condition is said to be K naught NC into root under OCR, where OCR is the over consolidation ratio. So it is the ratio of the pre-consolidated pressure to the present effective overburden pressure. So this thing need to be clear for the better understanding of the thing which we are discussing over here. Now we talk about the earth pressure at depth Z. So sigma H is K naught into sigma V, because when we are concerned about the concerned about what much, when we are concerned about how much stress in kilonewton per meter square acting at a specific section over here, so we are interested in getting the value as k naught into gamma into z. Okay, but if we are interested in calculating total value, so we are interested in calculating the entire area as 1 by 2 into k naught into gamma into z, gamma into z square, as it is mentioned also over here, and its location from the ground is as per the triangular law over here. The similar normal triangle is formed, and over here 2 ratio 1 concept is already clear that it is acting from 2h by 3 from the top or h by 3 from the bottom for our better understanding. So now we will see that the resultant pressure at the rest act at the height h by 3 from the bottom, and the pressure is denoted by P naught, and P naught is the total area of the triangular pressure diagram, as I already mentioned, which is came to be 1 by 2 into K naught into gamma into H square, where H is the total height. Now we move to the active earth pressure condition, but before moving in that direction, we will take a small break of 5 minutes. Afterwards, we will come and move ahead with the new contents, new concepts. So till that, take a 5 minute break and come after that. Right. So there is a 5 minute break for everyone. You can also take a 5 minute break. We will start after 5 minutes and move ahead. Hello. Okay, welcome back. Okay. See, so before going for a break of 5 minutes, we are talking about the Earth pressure theory. Uh, and we have discussed about the Earth pressure theory in the rest condition. We have discussed about how we calculate its location. Specifically, up to here, we are not talked about the stratified layer of soil. When we move ahead and discuss some question over there in which the soil in the above and below layer are of the different property, like the different C5 property. So over there, we first of all draw the Earth pressure diagram, and accordingly we make some changes to get at the desired result which we are willing to. Okay, so we will see over there. Not to worry about that at this point of time. At this point of time, what we are discussing, we will move ahead with that. Right. Okay. So now we are moved to the active earth pressure condition. In this condition, the wall moves away from the backfill as it is discussed earlier as well. But over here, the plastic equilibrium concept is there. As we have seen, in this condition, the soil, as we say, the plastic equilibrium, the soil refers to the condition where the every point in a soil mass is on the verge of failure, because at that condition it's get achieved in the plastic state. Okay, so the general formula for the lateral stress, that is the sigma h in the active condition, is sigma h equal to Ka into gamma z minus 2c into root k. It consider both for the cohesionless as well as the cohesive concept in one go, because if the value of cohesion is over there, we consider, and that what is the value of cohesion, what is the coefficient of earth pressure coefficient. For the calculation of earth pressure coefficient, that is K, we use the interrelation with the help of the value of angle of internal friction, that is phi. K as 1 minus sin phi by 1 plus sin phi, that is nothing but equal to tan square 45 minus phi by 2. So sigma h is, if we write by breaking in the different terms, we can write as sigma h equal to gamma z into tan square 45 minus pi by 2 minus 2c tan 45 minus pi by 2. So we get the value of the horizontal earth pressure which is acting over there. Right. Now we talk about the next condition in which the over here we talked about the earth pressure coefficient as 1 minus sin phi by 1 plus sin phi as the active earth pressure coefficient. So for the value of phi, suppose the phi equal to 30 degree, we use 1 minus phi, that is the angle of internal friction. The is equal to 30 degree, we calculate K as 1 minus sin 30 by 1 plus sin 30, or tan square 45 plus minus pi by 2. Over here the K is the active earth pressure coefficient, and how we calculate, we come across, and we also come to know that the phi is the angle of internal friction, and C is the cohesion of the soil, and those things we have already understood how to calculate during our previous lectures. Okay, now you see the pressure distribution diagram can be represented over here. You can see over there that the pressure distribution diagram is shown first of all in the first section at top. You see minus 2c root k is there. Okay, so it is explained. You come across these things. I will write it again. Okay, see, I will take my pen. Over here you can see that we have this interrelation sigma h equal to k gamma z minus 2c root k. For this condition, when z equal to 0, for z equal to 0, when we write z equal to 0, sigma h get become z equal to 0, so k gamma z become 0, so this value become minus 2c root k minus 2c root k, right? That is the case what we are discussing about over here. So when you see the diagram, earth pressure diagram, so at the top the value of minus 2c root k is there for z equal to 0. Accordingly, this value, the depth up to which over where the total stress is 0 is 2c by gamma root k. Okay, so 2c by gamma root k is that place, or 2c by gamma into 1045 plus 5 by 2, which is represented over here. When we calculate the double of that distance, because we are interested in calculate the total stress, so the point up to which where we calculate the stress is 0, because this is negative and this is positive. So negative plus positive equal to 0. So for that distance is the 4c by gamma root k. So that is the maximum unsupported depth uh, over there up to which the soil can withstand without having any scaffolding or any other support. Okay, after that the support is needed so that the k gamma z minus 2c root k ultimately you can see over there. So I think so this understanding is very much clear in everyone's mind. So you will see, for the cohesionless soil when c equal to 0, sigma h, that is k gamma z minus 2c root k, become k into gamma z, where k is the 1 minus sin phi by 1 plus sin phi, or 10 square 45 minus 5 by 2. So or the sigma h could also be written as gamma z multiplied by 10 square 45 minus 5 by 2. For this case, the negative side pressure distribution diagram will not be there because z equal to 0, sigma h equal to 0. So the earth pressure diagram is triangular starting from 0 at the top of the section, and it's go ahead if the soil property doesn't get changed throughout the depth at any point. Okay. Now you see the failure plane. Over here the failure plane is represented, and the failure plane in the soil make a 45 degree, 45 plus 5 by 2 degree angle with the direction of the major principal plane, that is horizontal. This These are called the potential slip surfaces. Over here, as it has been written that it make angle 45 plus 5 by 2, that is replicated, represented with the diagram as well in the figure. Now you see the Rankine earth pressure against a vertical while with a surface horizontal with the cohesion less, I think so, soil. Okay, cohesionless soil. So over here you can see that the wall is moving in the active state from the away from the backfill, and the weight is applied in the downward direction. Wall's initial position and wall final position is also represented. Wall initial position is AB and the final position is AB dash. So it's that value is also represented as R, and W is applied in the downward direction. So the value of PA is also represented with the help of arrow, and the runtime passive earth pressure condition in the cohesionless soil is represented to its whole. For a specific section in center, we also see that its value is acting at h by 3 from the base, and the value of PA is going to be 1 by 2 into k into gamma into h square. Now, when we talk about the lateral pressure acting against the smooth wall AB, okay, lateral earth pressure acting against a smooth wall AB is due to the mass of soil ABC above the rupture line AC. The lateral pressure acting against with the horizontal, the lateral pressure distribution on the wall AB of which make an angle 45 degree, that is equal to 5 by 2. Hence, the H increases in the same proportion to the depth, and the pressure act normal to the AB. So the lateral active earth pressure at A is PA equal to K into gamma H, which act at a height h by 3 above the base of the wall, and the potency and the total pressure AB is therefore calculated as follow. When we integrate the value of PZ at any depth Z, pressure at any depth Z dz from 0 to H, we see that the value is going to be k into gamma z dz for 0 to h, and when we calculate it, it is going to be 0.5 into k into gamma h square. As we have seen it earlier, the relation is linear. We calculate the area over there. We also came across the same interrelation, that is 0.5 into k into gamma h square, and where k is the tan square 45 plus 5 by 2. So we reach at the valid conclusion that the earth pressure coefficient is found as 1 minus sin phi by 1 plus sin phi, or this is the case. Now we consider the second condition, that the passive earth pressure condition. We have understood the same thing in the active, and now we are considering for passive. Okay. Okay. So for the passive, for the condition for the passive state of stress, in this condition, as it is already aware, you are aware about the thing that the retaining wall moves toward the soil mass backfill. So the formula and the expression are the quite similar to the active state. Some positive negative signs changes, for as it has been seen that the active and passive earth pressure coefficient are inverse of each other. So those relation good is also dependent over here. So the this is a very easy way to remember this formula as the general formulation of sigma h for the passive condition. When we talk about the general, we are not talking about the rain kind only, as it is the 2c k root k is added by the base. So this interrelation is modified for the cohesive soil is by the Bell theory is also it is said to be, but it is not mentioned over here in the theory anywhere. But over in this presentation, but this is the fact. So the Kp is going to be 1 plus sin phi by 1 minus sin phi, which used to be 1 minus sin phi by 1 plus sin phi for the active state condition, and sigma h is similarly going to be k gamma z into tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2, right? Now we talk about the pressure distribution diagram, and we say it is represented in this fashion as you have seen earlier for that case as well. So over here the 2c root kp is plotted for as the value, you know that we have the interrelation as k naught, we have interrelation as kp gamma z, kp gamma z plus 2c root kp, 2c root kp, right? So for this case, as we see, we say for at z equal to 0, at z equal to 0, we have the value of sigma h, that is this is sigma h, is or the passive earth pressure, whatever you say, is going to be 2c root kp. Okay. So over here you can see 2c root kp, and afterwards we draw the linear diagram afterwards, and we establish the interrelation which we are looking for. Okay. Now for the cohesionless soil, that is for C equal to 0. The expression of lateral pressure is given as sigma h equal to kp into gamma z, and the value of kp is going to be 1 plus sin phi by 1 minus sin phi, that is tan square 45 plus 5 by 2. So sigma h is going to be gamma z into tan square 45 plus 5 by 2. Okay, here some wrong thing is also mentioned. Oh, again, over here you can see the failure plane, as we have seen in the failure plane for the active state condition. Over here we can see the same thing for the passive state condition, and you can found that for the unkind passive state of slip surface, it make an angle 45 minus 5 by 2 degree angle with the direction of the minor principal plane, and this is in the horizontal direction. Again, similarly, when you see here The wall condition before and after is represented in the figure. Over here you can see the initial condition is AB and now it gets shifted to AB dash. So the value of passive earth pressure is applied and that is going to be in the similar manner at the location h by 3 from the base when we are going to calculate, but this value is more as compared to when we calculate for the active, as the coefficients and things are different in this case. Now you see one more very important thing, that is that is when we talk about in the cohesionless soil, the value of 2c root kp get eliminated, and for that case the wall AB is pushed into the mass to such an extent as to impart the uniform compression throughout the mass, and the soil wedge ABC in the figure will be the Rankine passive state of the plastic equilibrium. The inner rupture plane AC make an angle 45 degree plus 5 by 2 with the vertical AB, and the pressure distribution on the wall is linear as shown. The lateral pressure, earth pressure at A is P equal to K gamma H, which act at height h by 3 above the base of the wall, and the total pressure on AB is therefore going to be PZ 0 to H, and that is going to be K P gamma Z dz, and that is ultimately when we calculate for the entire height we come to know this value is going to be 1 by 2 into kp gamma h square. That is similarly the area when we are considering for a single layer of stratified soil. So sorry, single layer of soil is a stratified soil only. So the over here the value of Kp is also mentioned here. Now we move to the Coulomb wave theory. Up to here we are talking about the Rankine theory. Now we are moving the direction to understand the Coulomb wave theory. So what are the assumptions of the Coulomb wave theory and how we move over there? We will see and understand, as you are aware that when we are in the very second slide of the today lecture, over there we have seen some of the names in that picture. Over there the Rankine column that is written, we have discussed about the Rankine earth pressure theory in there for the active passive everything, and their modification for the cohesive soil, as it considered the 2c root k and minus 2c root k respectively for the passive and active, active state of stresses. So we will move ahead, and we found that the Coulomb wave theory provides a method of analysis that gives the resultant horizontal force on a retaining system for any slope of wall friction and the slope of the backfill provided. This theory is based on the assumption that okay, this theory is based on some assumptions, and what are those assumptions? Those assumptions are like those assumptions based on some assumptions. Um, Resultant theory fits retaining system at any wall. Okay, I will read it again. I missed some point. So the Coulomb theory provides a method of analysis that gives the resultant horizontal force on a retaining system for any slope of wall friction and slope backfill provided. This theory is based on the assumption that the soil shear resistance develop along the wall and the failure plane. The following coefficient is for the resultant pressure acting at angle. Since the wall requires a curved surface of the sliding to satisfy the equilibrium, the Coulomb formula will be given only approximate result as it assumes the planar failure surfaces. The accuracy of the Coulomb will diminish with the increased depth for the passive pressure. The Coulomb formula can also be inaccurate result when there is a large back slope or the wall friction angle. These conditions should be investigated and increase the factor of safety consideration. When we talk about its wave theory, we say that in the Coulomb in 1776 developed a method for the determination of the earth pressure, which has considered the equilibrium of the sliding wedge which is formed when the movement of the retaining walls takes place. The sliding wedge is torn off from the rest of the backfill due to the movement of the wall, and when we talk about this in the active earth pressure case, the sliding wedge moves downward and outward on the slip surface relative to the intact backfill in the case of the passive earth pressure. The sliding wedge moves upward and inward similarly for the same case, and the pressure on the wall is in fact a force of reaction which it has to exert to keep the sliding wedge in equilibrium. The lateral pressure on the wall is equal and opposite to the reactive forces exerted by the wall in order to keep the sliding wedge in equilibrium. The analysis is a type of limiting equilibrium method in which we consider the limit equilibrium case to calculate the results. When we talk about the assumptions which are made in this theory, we say that the backfill is dry, cohesionless, homogeneous, isotropic, ideally plastic, material, elastically undeformable but the breakable. The slip surface is a plane surface that passes through the heel of the wall, and the wall surface is rough as it is not considered in the case of the Rankine. The resultant earth pressure on the wall is inclined at an angle to the normal to the wall, where is the angle of the friction between the wall and the backfill. The sliding wedge itself acts as a rigid body, and the value of the earth pressure is obtained by considering the limit equilibrium of the sliding wedge as a whole. The position and direction of the resultant earth pressure are known. The resultant pressure acts on the back of the wall at one-third height of the wall from the base and is inclined at an angle of the normal to back. The angle is called the angle of wall friction, and the back of the wall is rough, and the relative movement of the wall and the soil on the back takes place, which develops the friction force that influences the direction of the resultant pressure. When we talk about this theory and move ahead, we say that in the Coulomb theory, a plane phase assumed and a lateral force required to maintain the equilibrium of the wave is found using the principle of statics. The procedure is repeated for the several trial surfaces, and the trial surfaces which gives the largest force for the active case, because over here the trial surfaces is very much important. So the trial surfaces which ultimately give the largest force for the active case and the smallest force for the passive case is actual failure surface. This method radially accommodates the friction between the wall and the backfill, irregular backfill, sloping wall, and the surcharge loading, etc. Although the initial theory was for the dry, cohesionless soil, and it has now been extended to the wet soil and the cohesive soil as well. The Coulomb theory is more general than the Rankine theory because it considers the several surfaces for the analysis before going to the result. Okay, now we talk about the Coulomb active pressure in the cohesionless soil. So over here, okay, over here we are talking about the Coulomb active pressure in the cohesionless soil. As we have discussed this point in the all the occasion when we are talking about the Rankine earth pressure theory for rest active and passive conditions. So over here you can also concern those points as well, as you say that the retaining wall with an inclined back force is sloping dry groundwork backfill in the active case. The sliding wedge ABD moves downward as you see this mm, in the picture over ahead, but the things are written earlier. So first of all I read and then I try to explain over there. So the sliding wedge ABD, in the figure it is represented. The sliding wedge is represented as ABD. Okay, so first of all, I will go ahead with the things. Okay, ABD moves downward and its reaction R act upward and the inclined at an angle F with the normal, the sliding wedge ABD is in equilibrium under the three forces which in which they are in equilibrium, which try to sustain the body in equilibrium are first of all is the weight of the weight that is said to be W, reaction R on the slip surface BD and the reaction Px from the wall, that is the wall reactions or the earth pressure in the real term. Okay, when we go ahead and we talk about for the condition of the yield of the wall away from the backfill, the most dangerous or the critical slip surface is that for which the wall reaction is maximum, and the wall must resist the maximum lateral pressure before it move away from the backfill, and the lateral pressure under this condition is the active pressure. The critical slip surface for the case of the passive earth pressure is that for which the wall has exert a minimum force to tear off the soil wedge by moving towards the backfill. And for this consideration, when we talk about this consideration, we say that the deficiency or the main deficiency in this Coulomb theory or the wedge theory is the assumption that the slip surface is planar. Therefore, the force acting on sorry, give me a minute. Hello. Okay. Okay, okay, no problem. So we are talking about a condition, the sliding wedge does not generally meet in the static equilibrium condition. The actual slip surface is curved, especially in the lower part. So the assumption of the plane slip surface do not affected materially the result in the active case, but give a very high value in the passive case as compared with the assumptions of the curved slip surface. When we talk about the principle of sliding wedge has been extended for calculating the earth pressure for the cohesive soil and for as we say the figure which is going to be represented next over there the force triangle get formed, and as the magnitude of the one force, that is the weight, and the direction of all the three forces are known, the force triangle can be formed. As we know that the sine triangle concepts in which the length and the angle subsequent to that we take by sine theta in that condition by which we compare and complete our calculation. So the magnitude of the PA is determined from the force triangle and the pressure acting on the wall is equal and opposite to the PA. The procedure is repeated, and after assuming that the another failure surface, the surface that gives the maximum value of PA is the critical failure plane and the corresponding force is the active force. When we talk about the Coulomb, okay, see, we are talking about the Coulomb method. Do not give a point of application of the earth pressure PA. The point of application is found to be approximately at the point of intersection and intersection E of the back of the retaining wall with a line C drawn from the centroid C of the failure to the wedge and parallel to the surface. As this procedure is commensable for the convenience, the pressure distribution is sometimes assumed to be hydrostatic on the back of the wall, and the resultant pressure PA is assumed to act on the one-third height of the wall from the base, but this is the assumption that is the exact case when we are talking about the Rankine theory, but over there the assumption it is taken to move ahead. So the some of the important points which one need to take care that the for the most of the practical cases the backfill moves down related to the wall in the active cases, and therefore the active force is inclined at delta angle below the normal. However, if the wall is supported on the soft compressible soil, it may settle to such an extent that the movement of the wall be downward relative to the backfill and the relative movement of the wedge will be upward. In such cases, the forces Pa would be inclined at an angle delta above the normal to the wall, and the angle delta is the friction angle between the soil and the wall. It may be determined by the means of the direct test. So when we see over here, as we are talking about the WP and R, you can see the expression for the active pressure for the cohesionless soil. Over here you can see in the first the alpha and beta has been represented and the direction of pH mentioned, and when it is broke out in the diagram in the right upper side, you see the W is acting in the downward direction, pH acting as it is shown in the figure A, and the value of the probable assumed surface which is said and its distance is also forecasted over here. Ultimately, the beta minus delta angle which is made at the upper part is represented and the W is in the downward direction. What is the phi value? That is the alpha minus the alpha is the angle which is represented over there. So that is the alpha minus phi dash is represented, which we discussed in our earlier calculation. As over there it is said that we apply the sine law. So we have applied the sine law to calculate the active phase, active force component of the weight vector from the figure. We obtain Pa by sine alpha minus phi equal to W by sine 180 minus beta minus alpha plus phi dash minus delta. Similarly, by doing calculation, we are come to know the value of PA. So, if the weight of the wedge weight is known, we are able to calculate the value of PA. From now, from the that figure above figure only, we say BE equal to AB B equal to AB sine beta plus I by sine alpha minus I, and AG equal to AB sine alpha plus beta, and AB equal to H by sine theta. Therefore, the weight of the soil wedge is W equal to 1 by 2 into B into AG into gamma into 1. So, when we solve this, we come to know W as gamma H square by 2 sine beta into sine beta plus alpha into sine beta minus I by sine alpha minus I, and everything is dependent over here. Similarly, we go ahead, we calculate the value of PA for as a function of alpha, and other terms given the problems are constant. So we are in the interested to find the value of PA, and by doing those calculation we are able to get the value of PA, and ultimately we are able to get the resultant force as well. That is calculation mentioned over here. You can go across that. That is not very much significant at this point of time to explain in detail because this is above the part of your syllabus. So I am not keen to explain those things over here. Now we move to the graphical solution for the lateral earth pressure theory. So that include the Kalman solution, trial gauge method, the logarithmic spiral method. The log spiral is also mentioned on the chart when you see the first slide. The Kalman solution is also one of the solution, but that is also not the part of our consideration. So we will skip those things and we will move to the question. So before going to question, I need a minute. So I will be back in a minute. I will be back. Hello. Okay, welcome. There is a little bit problem over here due to of some network or anything. That's why I have to wait, reconnect that. Okay, no problem. We will move ahead and we will solve some small problem before ending the today's session. So first question is that originally Rankine theory for the lateral earth pressure can be applied only to, as it is written in the very first slide, that it is applicable to originally cohesion less soil, right? So the option are cohesionless soil, cohesive soil, fine grained soil, coarse grained soil. So our answer is going to be cohesionless soil. Answer is also written over here as it originally proposed. Rankine theory of lateral pressure is applied uniformly to the cohesionless soil only. Later it was extended to include for the cohesive soil by the some other researchers or experimentalists. The Rankine theory of the lateral pressure, next question is Rankine theory of lateral pressure was extended to the other soil by Russell and Bale, Moore, none of the mentioned above or all the above. So I have said earlier Bell theory. So correct answer is option A. You see, as it is written over here that the theory of the lateral earth pressure was extended to the cohesive stratified particularly emerged in the subgraded soil by Russell in 1910 and Bell in 1915. As we move ahead, we see that the next question is coming up, which states that based on the assumption of the Rankine theory, the soil mass is stratified, submerged, homogeneous, or all the mentioned above. So this is the question which is asked from the assumption of Rankine theory, and I have said many times earlier as well, and today also that if some assumptions are there, that it become very much important for the solution. So we have read in the Rankine theory, soil is assumed to be homogeneous isotropic, but we have not talked about anything about the stratified submerged or anything else. So in the context of that, the correct answer needed to be homogeneous. Let's see. Yes, over here you can see that the answer is written that according to the assumption of Rankine theory, soil mass is semi-infinite, homogeneous, dry, and cohesionless. That's what we have mentioned. Okay, no problem. Now we will move to the next question. Next question mentioned over here say that which of the following cases of the cohesion less backfill in the Rankine theory is considered: submerged backfill, moist backfill with no surcharge, backfill with slope surface, or all the mentioned above. So our correct answer is as submerged backfill is also correct. Moist backfill with no surcharge is also correct. Backfill with sloping surface is also correct. So the correct answer is going to be option number D, that is all of mentioned above. Explanation is also here in which it is written that the Rankine theory of the following cases of the cohesionless backfill are considered as dry or the moist backfill with no surcharge, and the second is the submerged backfill, third is the backfill with a sloping surface and inclined back surcharge. As we go ahead, we see that the factor that is responsible for the inclination of the resultant pressure to the retaining wall is okay. The factor that is responsible for the inclination of the resultant pressure to the retaining wall is frictional force, surcharge, earth pressure, weight of the wall. So the correct answer is the friction force. So our answer is going to be option number A. Correct? I think so. Correct. There will be no doubt up to here. So we will move ahead. And okay, explanation is also here in which it says that the retaining wall are constructed of masonry or the concrete. Due to this, the friction force develops, and the existence of the friction makes the resultant pressure inclined to the wall at an angle that approaches the friction angle between the soil and the wall. And when we move for the next question, you see if the sand filled behind the retaining wall with the saturated water, then the possible lateral pressure due to the submerged weight and the lateral pressure due to water, lateral pressure due to retaining wall. None of the mentioned above or all of the above. So correct answer is going to be option number A. When we go in the explanation, we say that the lateral pressure is made up of the two components, that is the weighted soil in the backfill and the retaining wall. So the lateral pressure due to the submerged weight gamma dash of the soil and the lateral pressure due to the water. That's the fact. When we move for our next question in this section, it says that, okay, read the question. Okay, now I will read again for you. The question states that the earth pressure at rest exerted on a retaining structure can be calculated using theory of elasticity, Mohr theory of rupture, or none of the mentioned above. So over here at rest it is the theory of elasticity. So option B is the correct answer. As you see that the earth pressure at rest, if you are aware in the today lecture, this is already mentioned in the very initial part of the lecture over there. The elasticity term is told for the rest condition, and the plasticity for the active condition or the passive condition is mentioned over there. So, the explanation also states that the earth pressure at rest exerted on the back of the rigid unyielding retaining structure can be calculated using the theory of elasticity. And the next question is over here that the value of K naught will be what for the loose sand. Okay, so there is a table, and there is a value of saturated, unsaturated, and cohesive, cohesionless, everything is over there. So from that table, the answer is going to be 0.4, that is C, and this not need to be remembered as of my thinking, as it is asked over here. That's not the problem, but you can't remember the entire thing. You can just keep a small eye, and if required, that will be given for any problem if it is required, because this is not the correct way to ask this question. Now, the next question is that the expression of K naught given by Jackie is K naught equal to 1 minus sin phi. As you remember, the value is K naught equal to 1 minus sin phi. So over here 1 minus sin phi in the first option, 1 minus cos phi in the third option. So our answer is 1 minus sin phi. As you are aware about that, it is captured or computed by Jackie in 1944. So this is the correct answer for the given question. Now move to the next problem, that is the question number 10, which state that what will be the coefficient of earth pressure at rest for a rigid wall. The backfill consists of the cohesionless soil having phi equal to 26 degree. So the first of all find the important term. It is asking the coefficient, and then it is saying at rest, and then it has given the value of phi at 26 degree. So for the rest condition, the value of is going to be k naught equal to 1 minus sin phi, that is 1 minus sin 26, and that value is going to be 1 minus sin 26 as 0.5616. So the correct answer is C. Yeah, over here explanation also written that the coefficient of earth pressure K naught can be calculated using the Jackie formula. Given phi equal to 26 degree, as we use the interrelation K naught equal to 1 minus sin phi, that is also mentioned above here. So the K naught equal to 1 minus 0.4483. So the 0.5616. Option number C is our correct answer. As we move for the next problem, which asks that the coefficient of active earth pressure is blank, then the coefficient of passive earth pressure. As it has seen, for the 30 degree, you can check by using your calculator. You check 1 minus sin 30 by 1 plus sin 30, that is going to be 1 by 3. And when we calculate converse 1 plus sin 30 by 1 minus sin 30, that is going to be 3. And both are the inverse of each other. So the coefficient of active earth pressure is less than the coefficient of passive earth pressure. So our answer for this problem is going to be option number A, that is less than. You see, it is also written and the clarification is also given. In the clarification, they mentioned that the coefficient of active earth pressure is less than the coefficient of passive earth pressure. The coefficient of active earth pressure is also less than the coefficient of earth pressure at rest. Exactly. And when we talk about the second problem in this section, that asks that the coefficient of earth pressure is at rest is less than the coefficient of active earth pressure. So the answer is already given in the previous problem, that it is greater than, because in the active is the least, because over there the soil get relaxed and as the wall is moving away. So in the rest condition the wall is over there only, and it is not moving away from the backfield. So that condition is also the condition over there. The coefficient is relatively more as compared to coefficient in the active condition. It is also mentioned in the explanation that the coefficient of earth pressure at rest is greater than that of the coefficient of active earth pressure, but the coefficient of earth pressure at rest is less than the coefficient of passive earth pressure. Exactly, because the coefficient of passive earth pressure is much high, because in that case the wall is moving toward the backfill. So that relation lead to those problems in those specific mentioned condition. Now we talk about the for earth pressure at rest, there will be no vertical stress, there will be no shear stress, there will be no horizontal stress, or there will be. So option number C is the correct answer. Option number B is the correct answer. No shear stress, because for the earth pressure at rest there is a horizontal stress as well as the vertical stress. For the earth pressure at rest there will be no shear stress. Right, exactly rightly said. Okay. Now we move to the next question over here. It is saying that a lateral earth pressure at rest with respect to Poisson ratio. So you know that value of K as sigma h by sigma v, sigma h upon sigma v, and that is also mu by 1 minus mu, mu upon 1 minus mu, right? So over here you can see the option number. Okay, you have to do the calculation. So see, so first of all sigma h um, multiplied by 1 minus mu. Okay. Okay, so see the option C. Option C, it is written sigma h equal to mu into sigma h plus sigma v plus sigma v. And when we do our calculation and we take the common sigma h, the value is going to be sigma h. When we take the common, the value is going to be 1 minus mu, and the second value is going to be mu into sigma v. And when we calculate sigma h by sigma v, we come across mu by 1 minus mu. So the option number C is the, sorry, we need the eraser, then we need a pen. Option number C is the correct answer. Over here, the explanation is also mentioned, but my calculation shown is far better. Okay, the next problem, the solution is also already mentioned. The coefficient of earth pressure at rest condition is given by mu by 1 minus mu. Fraction that is mentioned over here, so leave it. And the question is also not mentioned in the correct order, but the solution is already mentioned. So the option number A is going to be our correct answer. Now we move to the next. The pressure distribution diagram for the earth pressure at rest is triangular because you are aware that it is going to be plotted in this fashion. K naught gamma h is the value over here for the rest condition. K naught gamma h for the height h, right? So it is going to be triangular. Right. The classification is also mentioned that the pressure distribution diagram for the earth pressure at rest is triangular. If the retaining wall has the height h, then the pressure at the base is k naught gamma h, and at the top of the wall is zero. That is also mentioned. Now talk about the coefficient of earth pressure at rest is represented as the expression by Jackie. I think so. This question is already asked, and you have answered as well. That is 1 minus sine phi, and the option number A state that 1 minus sine phi, and the explanation is also mentioned here. As we move ahead, the question is said that the question describes the angle of internal friction 45-degree, value of K naught. This question is also already asked. I think so. As it is asking the value of K naught as 1 minus sine 45. 1 minus sine 45. Sine 45 by 1 by root 2. Sorry. Right. So you can calculate accordingly, and the value is coming to 0.293. So option number C is the correct answer. Now, when we move to the next question, we see that the backfill of the retaining wall consists of gamma equal to 19 kilonewton per meter cube and the height of 6 meter. Find the total earth pressure per meter. Coefficient of earth pressure is also mentioned as 0.5. So 1 by 2 into k gamma h square. K gamma h square is the solution. So you calculate 1 by 2 into k 0.5 kilonewton per meter. It is asking k into gamma. Gamma is 19 and height is like 6. So going to be 36. When you calculate this, you are going to get the value as 171 kilonewton. So option number C is the correct answer. Right? When we move to the next problem, the value of k naught is given and mu is asked. So mu by 1 minus mu equal to 0.4. When you do your calculation as mu equal to 0.4 minus 0.4 mu, right? And mu, when we get over here 1.4 mu equal to 0.4, and when you calculate the value of mu, you will get the value as 0.286 is the correct answer, right? This much calculation you can do, and it is also mentioned in the solution as well. Now again the question for mu equal to 0.3, value of k naught is going to be, so use the interpretation k naught equal to mu by 1 minus mu, k naught equal to mu upon 1 minus mu. Once you use this relation, you are able to get the solution as the value of 0.429, right? When we move to the next problem state that the backfill of the retaining wall consists uh, of gamma equal to 90 kilometer. Okay, this question is already asked and already answered as well. So I will not going to solve this again. This is the 57 is the correct answer, and all things are mentioned here. It, and with this, you have solved. This is the problem from the foundation engineering for the entrance exams. Right. Most of the question I asked from the entrance exams sections only. Okay. So output what we get from the today discussion. For the entire discussion, we have understood the Earth pressure theory at rest, and unkind theory, that is the active Earth pressure theory, passive Earth pressure theory. We also come about to know the Coulomb wave theory and some other aspects. So those thing understanding we get developed. Now the some homework for you. The homework is that you go at home, your home place, and try to write the answer of this question, that is the, what is the Rankine theory, what are the assumption of Rankine theory, and then there are the many problem available in the books of any of the geotechnical engineering books you have. You can go across those books and solve some problem related to Rankine pressure theory at rest in active and passive condition. So we'll develop a better idea or about the subject. If you still have any doubt with the concepts which will be discussed and the problem which we have solved in the today class, you can ask those problems in the next class. These are the some references from which the content is also prepared, and the books names are also mentioned here with apart from the book which are mentioned in the NPTEL coursework. You can go across any of the books to solve the problem and get a better idea of your concepts. Now, with this, I will sum up the today's session. Thank you everyone for joining for the session. We will meet you in the next session at the next Saturday at 3 p.m. So, thank you everyone for joining. Thank you very much. Wish you a very happy weekend.